Alright, so this video is going to be about finding the magnitude and component form of a vector. If you need something else dealing with vectors, you can check my other videos, but this one's just going to be about simple operations with a vector in the sense of finding its magnitude and then also being able to write it in a component form. So one thing about a vector is that a vector is a quantity that has two quantities that go with it. So it's something that has two quantities. It's got magnitude and it has direction. And so this video is going to be about the magnitude. And so a vector is normally represented with, if you will, it's normally represented with an arrow from an initial point. So if I were to pick an initial point at, say, -3, 1, I'll call it P. So -3, 1. And then if I pick a point at, let's say 3, -2, and we'll call it Q, a vector is going to be represented by an arrow that goes from P to Q. Oops, almost missed it. From P to Q, and so it has a starting point, the terminal initial point P, and it has an ending point Q, and it's not going to go past the ending point. So it has direction. You can see it. It's got a direction where it goes down and to the right in the coordinate plane, but it also has magnitude. So the magnitude is going to be the actual length of the arrow. So if you can imagine, how could I find the length of this arrow? And in class, I had students who would make this into a right triangle, right? And then they said, oh, it's like a right triangle, and so I could just use the Pythagorean theorem. I count down 3, I count over 6, and now I can use the Pythagorean theorem. And so that's one thing they did, to which then it brought up the point, what else could we do other than the Pythagorean theorem? And so what we did was we talked about the distance formula. So PQ is represented by that statement. So that's the vector PQ, and it would have a magnitude with 2 bars like this. This is how we would represent magnitude. And so if somebody said, what's the magnitude of PQ? We would want to find the distance between the 2 points. And so the way we're going to do that is we're going to use this formula, and it's going to be the square root of the x value of Q, so I'm going to call it Q sub 1, minus P sub 1, so that's the x value of P squared, plus Q sub 2 minus P sub 2 squared. And so it's just a variation of the distance formula where we subtract the x values, square it, which would be this one, and we subtract the y values, square it, and then we add them together in square root, and you'll have the distance, which would be the magnitude of PQ. So let's just do this one for example. So the magnitude of PQ is going to be the square root of, and we'll take the x value of Q, so 3 minus -3 squared, plus, and then we'll start with Q again, -2 minus 1 squared. So we've got the square root of 6 squared plus -3 squared. And so 6 squared is 36, and -3 squared is 9. And so we'll have 36 plus 9, which is 45. And we'll simplify that. And so the magnitude of PQ is going to be, I'll give you a second to simplify it. Hopefully you got it. 3√5. And so that's our distance of the vector. And so vector, once again, has direction and magnitude, and this video is about magnitude. So how do you find the magnitude? You just do the distance formula. And so that's all we're going to do. Sorry, that's a phone call. I'm in my office. Of course, I would be getting interrupted while doing this, but it's all good. So, so you can find the magnitude of a vector and you can also find the direction, but we'll do that in another video. So let's just try the magnitude one more time, and then I'll talk about the component form. So let's say that the initial point for this example, the initial point is 10, 15, and the terminal point where the vector would end is going to be, let's say 4, and let's go with 8, 7, 4, 7. Okay, so you don't have to draw it if you don't want it, but to find the magnitude, all we have to do is use that distance formula. So we'll call this P, we'll call this Q. Magnitude of PQ, once again, is going to be the square root, and we're just going to start with Q again. Remember that. So 4 minus 10 squared plus 7 minus 15 squared. You get the square root of negative 6 squared plus negative 8 squared. And so we'll get the square root of 36 plus 64, and if you can see that, that's going to be 100. So the magnitude of PQ is the square root of 100, which is 10. So every vector has a magnitude, and the way you're going to find it is just by doing the distance formula, and it's a variation of the Pythagorean theorem. So if you ever get stuck, you could always use the Pythagorean theorem if you graph the 2 points and create a right triangle. Now let's talk about this example. What would the component form be? So let's say we were asked to put PQ into component form. So if we were asked to put PQ into component form, what component form is it's a way of writing a vector, and let's call that vector V, and you would have these weird brackets, and it's V1 is the horizontal component, and V2 is the vertical component. And all vector form or component form says is V1. V1 is going to represent how did the point from P to Q move horizontally. So if we look at it, P started at 10, and then Q ended at 6. So if you think about it, it went from 10 to 4, and so there was a direction of, look over here in this distance formula, right? There was a horizontal movement of -6. So the vector component form is going to be V equals -6, and you just do 4 minus 10, comma, and then for V2, it's the vertical component, and so you just look again at P and Q right here. So 15 is where it started, and then it went down 8 to get to 7, so there was a -8 vertical movement. So -8 would be that component form. Now why is this important? So this component form is the same vector as the one up above. It's just now not going to start at 10, 15 and end at 4, 7. Where it's going to start is this one is going to start whenever it's in component form. It's always going to start at 0, 0, and then it's going to go however it says. So it's going to go left 6, 1, 2, 3, 4, 5, 6, and then down, right, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Oh, that was not a good 8. There it is. So now it'll go to about right there, and we could draw our arrow. So while it's the same vector as the one up above, its initial point is now going to be 0, 0. And this becomes a lot more useful in things like vector operations and finding the direction angle and a lot of other things. So if you can put a vector, rather than having the 2 points, if you can put it in component form, it becomes a little bit more useful to you later on. So all you do is you subtract the x values, right? So once again, to find that, it would be Q1, the x value of Q, minus the x value of P, and V2, you just do Q2 minus P2, which makes it even greater. And I'll just end here. If you were asked to find the magnitude of something in component form, all you have to do is the magnitude of v. If you see it, this is that part of the distance formula, and so all you have to do is the square root of v1 squared plus v2 squared. And so in this up above, you just square -6 and square -8, add them together and square root, and that would be the distance of our vector. Okay? Well, thanks for watching. Hopefully you're doing well. Have a great day. Bye-bye.